Hi, welcome back to another video. In this video, we're going to talk about set operations with 3 sets. So in a previous video that I did, I only talked about set operations with 2 sets. And so this time I'm going to talk about 3 sets. So I just have some examples that we're just going to jump in and do and just figure out how to perform these operations with 3 sets. Okay, so one of the things I want to point out first is that whenever you perform set operations with 3 sets, there is still an order of operations. Just like when you're doing algebra, you have to work in a certain order, and you will start with what's in the parentheses. Please excuse my dear Aunt Sally if y'all remember that. You want to start with parentheses with set operations as well too. So let's look at this first example that I have up here. We have let u equal the set with 1, 2, 3, 4, 5, 6, 7, 8, and 9 in it. A is the set with 1 through 5, B is 1, 2, 3, 6, and 8, and C is 2, 3, 4, 6, and 7. And we want to find or perform some operations on these sets. For the first part, we want to perform this operation A union B intersects C. And so just like I mentioned earlier, you want to start with the parentheses. So B intersects C is in parentheses. So I want to figure out what is the set B intersects C. So recall the intersection of 2 sets means that is the point where those sets overlap, or that is the set that contains all the elements that are shared between those 2 sets. So if we look at B and C and we look to see what they both have 2, they both have 3, and then they also both have 6. So the set B intersects C would be the set with 2, 3, and 6 in it. Alrighty, so that's this part. So now we want to do A union with this set B intersects C. Okay, so remember, union means you take everything from both sets and you bring it together. So whenever you unite 2 sets, basically, you're just bringing all of their elements together. So A union B intersects C would be me taking everything that's in A and combining it with everything that's in B intersects C. So A has 1 through 5. And then this B intersects C has those 2 and 3 already. I don't have to list those again, but it also has 6. So I would include 6 in that set. And so this would be the set operation A union B intersects C. It will be the set with 1 through 6 in it. Okay. For part B, we want to do the set operation A union B intersect A union C. And so in this case, we have 2 sets of parentheses. So we want to perform the operations in both sets of parentheses. So A union B is the first parenthesis, so we want to take everything. Remember, union is bring everything from those 2 sets together. So we want to take everything in A and everything in B and list it in one set. So A has 1 through 5, and then B also has 6 and 8. Alrighty, and so now we want to do the same thing with A union C. So we just figured out what that set is. Now we want to figure out what this set is, A union C. So A union C is you want to take everything in set A and everything in set C, and you want to combine them together. So A has 1 through 5. C has 2, 3, and 4, but it also has 6 and 7. So that's the set A union C. So we've done the operations in parentheses. Now we want to do the overall operation, which is to take the intersection of those 2 sets. So A union B intersect A union C. We're going to look at these 2 sets and see what they have in common. They both have 1, they both have 2, they both have 3, they both have 4, they both have 5, and they both have 6. So that set will look like this. The set with 1 through 6 in it. For the last part of this example, part C, we want to find A intersect B union C prime, or the complement of C. Okay. So in order to do these parentheses first, I need to first know what is the complement of C. So let me figure out what is C complement first. So remember, C complement is all the things that are in the universal set that are not in C. So our universal set has 1 through 9. And so C complement will be all of the things that are here but not here. So that would be 1, that would be 5, we got 6, 7, that would be 8, and that would be 9. So that is C complement. Now I can do the inside of these parentheses, which is B union C complement. So that means I take everything from set B, everything from set C complement, and I put them all together. So B union C complement would be So B has 1, 2, and 3 in it. And then C complement has 5. And I'm just going back and forth because I want to list them in order. So then B has 6 in it. B has 8 in it. And then C complement has 9 in it. So that's what B union C complement would look like. And so now I could do the overall picture, which is to take A intersect B union C complement. So I want to take the intersection of this set and A. So basically see what do they have in common. So they both have 1, because A has 1, 2, 3, 4, and 5. So these are going to be the only 4 that they have in common. 1, 2, 3, and 5. So that would be A intersect B union complement. And so this is how you will perform operations with 3 sets. These are just some examples, but there's a lot more that you can do. And so let's work another example. Okay, for example 2, we have a Venn diagram that has 3 sets. It has 3 sets, A, B, and C. And just in case it's kind of hard to see, let me just go ahead and... Okay, so just so you can see, I've zoomed in on the Venn diagram. And in this part, there's 11 and 3. In this little region right here, there's 6. In this middle region, it's 5 and 7. And then that's 12. Then we have 1, 2, and 10. We have 9 in this region, 8 here. And then we have 4 out here. So I just wanted you to be able to see it. I'm going to zoom back out so that we can work some problems. With this Venn diagram, we want to find 3 different things. We want to figure out what is set A, what is set A union B, what is set B intersect C, what is C complement, and what is A intersect B intersect C. So the intersection of all 3 sets. So starting with set A, so part A is set A. That's just listing all of the things that are in set A. So now set A is this circle right here. So everything contained within this circle is the element of set A. And I'm just going to list them in order. We have 3 right here. Inside this little part, there's 5 and 7. And then there's 6 right here. So I'll put 6 and 7. Then I have 11 and 12 right here. And so that would be your set A. The set with 3, 5, 6, 7, 11, and 12. All right. Then for part B, we want to find the union of A and B. So it's going to have all of this plus the additional stuff that's in B. So everything in this circle here is B. Now notice B and A share 12, 5, and 7. 5, 7, and 12 they have in common. But B also has 1, 2, 10, and 9 that A doesn't have. So when I create my set for A union B, I will add the 1, the 2. So I have the 3, the 5, the 6, and the 7. And then I will also add the 9 and the 10. And also 11 and 12. And so that would be the union of A and B. 1, 2, 3, 5, 6, 7. 1, 2, 3, 5, 6, 7, 9, 10, 11, and 12. That is the union of those 2 sets. All right. For part C, we want to do the intersection of B and C. So remember, intersection is what they share. So here is set B and here is set C. And then the intersection is this part right here. I could try to make it a little bit bolder. And it has 5, 7, and 9 in it. So the intersection of B and C will be 5, 7, and 9. For part D is C complement. That means the things that are not in C. So C is this circle right here. So everything outside of that circle would be a part of C complement. So if I start with my smallest one, 1, 2, and on the homework, I don't think it's required for you to list them in order. It's just what we call proper mathematical etiquette to list them in order from smallest to biggest. So we have 1, 2, we have 3 over here, 4 in the outside. That means it's not in A, B, or C. Then we also have 10, 11, and 12 that's not in C. So that is C complement. And I'm sorry if y'all hear the airplanes. I live in the, in the pathway to Bush Airport. So I hear planes coming back and forth all day. And my neighbor decided to mow their yard a while ago. So you probably also heard the lawnmower and weed eater going off. So sorry, but hopefully you can still focus with the additional sounds in the background. So that's part D. And then part E is the intersection of A, B, and C. And that is what A, B, and C share. And so that's going to be this middle region right here. That's where all three of those sets intersect. And that's the set with 5 and 7 in it. And so that's the intersection of A, B, and C. So that's set operations, but this time, so it's set operations with 3 sets, but this time we're using the Venn diagram to perform the operations. All right, let's look at one more example. For this last example, we want to construct a Venn diagram illustrating these sets, A, B, and C, and this universal set. And so I already have like the skeleton of 3 sets here. And so what we need to do is go in and fill in these letters where they belong. Okay, so now when you are constructing a Venn diagram, especially with 3 sets, you want to start with the innermost overlapping region and then kind of work your way out. So there are some things that we need to figure out before we start filling in the letters. And the very first thing we want to figure out is what is A intersect B intersect C, meaning where do all 3 of those sets overlap? That is this innermost region right here. And so what we would do is look at A, B, and C and see what do they all share. So they don't all have A. And the best way to do this is to really look at the set with the smallest number of elements, that has the smallest cardinality, because the smallest set, that's going to be the smallest that your intersection can be, basically. So they all don't have A, they all don't have C, they do all have E, and they do all have H. So that means the intersection of all 3 of them will be E and H. So I would start by putting E, and I know this is really small, but putting E and H in that intersection of all 3 sets, in that innermost region. That's an E and an H right there. Okay. And then I would next want to see, what does A and B have in common? So where do A and B intersect? They both have E, they both have G, and they both have H. So that would be E, G, and H. So that means A and B, this whole region right here, should have E, G, and H in it. Well, it already has E and H, so it's missing a G. So G would go in this portion because it's in the overlapping region, but it's not in the overlapping region for all 3. Okay. Now I want to figure out, what do A and C have in common? And you don't have to go in this exact order as far as finding the intersection of the 2 sets, but you do want to start first with the intersection of all 3 sets. So what do A and C have in common? So again, they both have A, they don't both have C, they both have E, and they both have H. So they have A, E, and H in common. Well, if you look at the intersection of A and C, it is this region right here. You already have the E and H in there, so the only thing that's missing is the A. So the A will go in that part where A and C overlap, but it's not in the overlapping region of all 3 sets. And then the last one, you want to see, what does B and C have in common? So B and C, they don't both have A, they don't both have C, they both have E, and they both have H. So B intersects C is the set with just E and H. And if you look at the intersection of B and C, it already has E and H in it. That means that you don't have to add nothing to this region right here, because that's the only overlapping part of B and C. Okay, so now we can go in and fill in the rest of the letters from the set. So basically A has A, D, E, G, H, I, and J. But if you notice, A is already in there, E is already in there, H is already in there, and G is already in A. So the only thing that's left is D, I, and J. So that's what will be in this region right here, the D, the I, and the J. And then if you go to B, B already has G in it. It already has E and H in it. So the only thing that's left is the little B and the L. That's an L right there. So B and L will go in this outside region that B doesn't overlap with any of the other sets. And then if you look at C, it already has C already has A in it. It already has E in it, and it already has H in it. So the only thing that's left is C. So C would go in this region right here. Now, when you look at the universal set already has A in it. It already has B in it. It already has C, it already has D, E. There's no F in there. So F would go out here on the outside. It didn't have an F, so we had to put F on the outside. And then it already has G, it already has H, it already has I, it already has J, but K, it doesn't have a K, so you would add a K on the outside as well. And then it already has L. And so that would be your universal set. So this is what your Venn diagram would look like. And I'm going to zoom in for you just so you can make sure you see all the different parts. Okay, so this is the Venn diagram zoomed in on, and hopefully you can see all the different parts. And it's still hard to see the E and the H in the middle, but that is E and H in the middle. And then there's a G right here. This is G right there, and that's A. So hopefully you can make out all the different parts of the Venn diagram. So this is how you will perform set operations with 3 sets. If you have any questions whatsoever, feel free to put them in the comments, or you can email me personally and I will respond as soon as I see your message. So thank you for watching, and I will see you all in the next video.